Okay, so here is step 1 for the practice exam points back. So same as before, you don't have to take notes on a problem if you got it right and you completely understand how to do it. This part is important. You really have to be honest with yourself about whether you just guessed or you got lucky, because if you did, then you want to understand how to do the problem. So you would want to take notes. Alrighty, so this is a no calculator section, and I can't show you the problems, but you have your test in front of you, so just refer to that for the original problem. Oh, no, you have this in front of you, and I didn't block this out. Okay, so here's a similar example. So always ask yourself if this is a limit, a derivative, or an antiderivative. So this is an antiderivative, okay? So I have to think of my antiderivative techniques, and nothing works, so I have to try u substitution. So I will let u equal 4x. So then du is 4 dx. So then dx is a fourth du. So then I take this and I do the substitution in for it. So I have the integral, and then this is going to be secant squared of u, and then in for the dx I'm putting a fourth du. Now if you have a constant multiple, I would bring it out front. I think that will make things easier. Okay, now we have not taken the antiderivative yet. We still have to do that. Now we've just used u substitution to rewrite it as something that's easy to take the antiderivative of. Now this is only easy if you know the formula. So the derivative of tangent is secant squared. So therefore the antiderivative of secant squared is tangent. So the 1/4 just comes down, and then the rest of it, which is this part, is the antiderivative of secant squared, which is tangent of u, and then plus c at the end. And then the very last step is you plug the u back in. Okay? So you're going to do work to correct this problem. Okay, so do enough work until you can see the right solution. Now these are multiple choice problems, so you want to go as fast as you can. So if you don't follow through on the whole problem, if you just do enough work until you can pick the right answer, that's great. Okay, so this next example. Okay, so this is similar to number 2. So this is a limit. So you ask yourself, limit, derivative, or antiderivative? So that's a limit. So you think of your limit techniques. You always try direct substitution first. So 0 goes in, I end up getting 0 over 0. Okay, so 0 over 0. So you could use L'Hopital's rule. However, if you use L'Hopital, you're going to have to use L'Hopital's rule a few times, because if you use it once, you're going to get 0 over 0 again. If you use it again, you're going to get 0 over 0 again. So I actually, this is a little, in this case, a little faster than L'Hopital's, ... is to go like this. All right, so this is a limit as x approaches 0, and then you take out, I'll take out a greatest common factor of x. Shoot, is this going to work? Huh. I think, okay, if I take out x to the 5th, oh shoot, it's not going to work. Because in here, what do I want? I just made this problem up. So x to the 5th, x to the 7th. All right, let me make this x to the, let's change that 12 to a 6. Okay, change that 12 to a 6. So I take out an x to the 5th, and I got x squared minus 2. I'm just factoring this. And then I can take out an x to the 4th, and I get 5x squared minus 3. Okay, yep. And the, crap. Is this working? Okay, darn it. Okay, it will work, I guess. All right, and so this x to the fourth completely cancels with 4 of those factors up here, so we just get an x left over. So this is the limit as x approaches 0 of x squared minus 2 over 5x squared minus 3. And then you repeat, so you try direct substitution again, and you end up here with getting 0 over negative 3, which is equal to 0. Okay, so the limit of this up here is 0. Okay, now here is the next one. So what we want to do is we want to find the k. Find k that makes this continuous. Okay, so find k that makes f continuous. And guys, you always ask yourself, you know, limit, derivative, or antiderivative. And with continuity, it's you do a limit. All right, you want to make sure that the left-hand limit, the limit from the left and the limit from the right, are equal. So I have to say to myself, as x approaches 1 from the left and as x approaches 1 from the right. I'm not using limit notation here. This is just a little bit faster. So as x approaches 1 from the left, right, so I'm doing a limit basically, then f is approaching, so that's approaching 1, so this whole thing is approaching 6. And then from the right, f is approaching, the x's are approaching 1, so this is approaching k plus 4. Okay, now in order to have a continuous function, the limit from the left and the limit from the right have to be equal. So now you just set them equal, so we get that k is 2. Okay, so we have to always ask limit, derivative, antiderivative. Which of those? Next. So f of x is this. Find f prime of x. Okay, this is a derivative. Limit, derivative, or antiderivative. So this is a derivative. If you have a trig function, sine, cosine, or tangent, or secant, or any of those, to a power, it will likely help for you to rewrite it like this, okay? Alrighty. And then, guys, this is actually double chain rule. This is an in, out situation. The innermost function is 7x. And that is inside of tangent. And then tangent is inside of blank to the 5th. So now you take the derivatives of all of these. So that's 7. That's secant squared of blank. And what goes in the blank is what was in there before. So whatever was in the blank before goes back in. And then this is 5 blank to the 4th. So what was in here before was tangent of 7x. And then this 7 and the 5 you can multiply. So this is 35 secant squared of 7x, tangent of 7x, but to the 4th. So I'll go like that. Okay. Moving on. Okay, so this next one. So here's f of x. We're going to find the equation of the tangent line at x equals 0. So the big question we ask ourselves is limit, derivative, or antiderivative. And for the equation of a tangent line, you've got to find the derivative. Okay, that's not all you've got to do, but that's something important. So for the equation of a tangent line, we need the point of tangency, and we need the slope, which in this case is f prime. So that's where the derivative comes into play. Okay, now for the point of tangency, we know that the x-coordinate is 0. And now for the y-coordinate, you've just got to get f of 0, the original function at 0. So if I plug 0 into here, I get negative 2 to the 3rd, which is negative 8, times negative 1. Negative 8 times negative 1 is just 8. Okay, so that's the point of tangency. Now, the derivative. Okay, so I guess I'll do it like down here. So, f prime of x. Now, first of all, this is a product. Think of your derivative techniques. You try power rule first, always. It's not going to work here. Then you try quotient rule or product rule. Here I have to try product rule. And I'll write it, I'll go really slow here. Okay, so we're going to go bracket prime bracket plus bracket prime. And what goes in here is 4x minus 2 to the third. And then this is just x minus 1. And then this is 4x minus 2 to the third and x minus 1. So I'm taking the derivative here and the derivative here, and then these are just going to come down. So for the derivative of this one, you need chain rule. So the inside is 4x minus 2. The outside is blank to the third. Derivative of the inside is 4. Derivative of the outside is 3 blank squared. So 4x minus 2 goes back in. All right, so that's this part. This just comes down. Plus, this just comes down. And then the derivative of this is just 1. So this is it. All right, so that's f prime of x. But up here, I need f prime of 0. Okay, and that's going to be the slope. So if you plug in here f prime of 0, okay, so f prime of 0, you end up getting 4 times 3, no, 4 times 3 times 4, I think. Yep. And then this is times negative 1 plus negative 8. All right, that's 12 times 4 is 48, so that's negative 48 minus 8. This is, I think I'm doing this right, this is negative 56. All right, so the slope is negative 56. Okay, that's a big slope. And now you've got to take this information and plug it into the point slope formula. So y minus blank equals blank, x minus blank. So in here goes our y coordinate, and here goes our slope, and in here goes the x coordinate. Okay, so I'm just going to stop there because I think you got the idea. Usually for multiple choice, you'll have to keep simplifying. Or actually, guys, you, I think, in the problem above can stop as soon as you find the slope. I'm pretty sure there's only one line with that slope. So that would save you a lot of time. Anywhere you could save yourself time is a great idea. Okay, now I'm going a little bit out of order just because of space issues on the paper. So we're going to do number 5 next. Okay, so if you're looking to see if you got it right, you're going to have to flip. Wait, what am I doing? Oh, darn it. Okay, this was number 6. Okay, so I should have mentioned that. That was number 6. So now we're going back to number 5. So we're going to find the x-coordinate of the relative maximum of this. So the big question, limit, derivative, or antiderivative. If you hear relative max, you're taking the derivative. Okay, so you know you got to take the derivative, so that's what I'll do. F prime of x equals 3x squared minus 6x minus 45. Okay, and then we've got to find the critical numbers. Okay, so the critical numbers are where the derivative is 0 or undefined. So I'm going to find where it's 0. It's never undefined because it's a polynomial. I can divide everything by 3. So this is x squared minus 2x minus 15. All right, this factors nicely. X minus 5, x plus 3. Okay, so we get x equals 5, x equals negative 3 for our critical numbers. Now, this is an f prime number line, and I'm going to think about the signs. So here we've got -3, here we've got 5. All right, I've got to pick a testing point in each section. And guys, I'm circling these the same color because when you do your testing points, you want to plug into the factored form of the derivative. This is the f prime number line, so that's why we're plugging into the derivative. So pick a number over here, like -10. If you plug it in here, you'll get a negative. Plug it in here, you'll get a negative. So that's a positive interval. I'll pick 0. Negative times positive is negative. I'll pick 10. Positive times positive is positive. All right? Now, relative max, we're looking for a sign change from increasing to from positive to negative. So it's here. So max at x equals -3. Okay? So this one, number 7. So this limit derivative or antiderivative, this is an antiderivative. So you think of your techniques. First power rule every time. Then you think about f prime over f and formulas and all these things. None of them will work. So you've got to do the U substitution, all right? So you look for a function that is inside of another function. I see this radical x inside of the sign, okay? So I'm going to let u equal radical x. So then du is equal to 1 over 2 radical x. Guys, if you want to convert this to x to the 1/2 and then do the power rule, that's fine. But I really like just having memorized that the derivative of this is that. It's so much faster, okay? So I got to solve for dx. So dx is 2 radical x du. Okay, now I'm going to do that substitution. Now here's the thing, guys. I let u equal radical x. But if I plug u in for both of these, then this x here is not going to end up canceling. So I can only plug u in for one of these. And when I chose this u, I chose it because it was inside of another function. So that's what the u is going to be, is this one up here. This one is going to stay radical x, because if it doesn't, then I'll run into trouble because the x's won't cancel. So this is the integral sine of u over radical x, and then I'm plugging this in for dx. So this is times 2 radical x du. And then this is exactly what I was talking about. So now those cancel. I'm going to pull the 2 out front. Okay. Now the 2 just gets carried down. And then I've got to take the antiderivative of that. Yeah, and guys, remember this thing? Okay, so sine, cosine, negative sine, negative cosine. This is, okay, so it's the derivative, okay, going this way is the derivative, but going this way is the antiderivative. Okay, so this is the anti, I don't know if that's helpful, but the derivative. Okay, so I want the antiderivative of sine. So here's sine. So the antiderivative of it is negative cosine. So this is 2 times negative cosine of u plus c. And then final step, this is negative 2 cosine of radical x plus c. Okay? Whew, this is taking a long time. Okay, number 8. So, this is a similar example to the one above. So f is continuous. That's important because if f isn't continuous, we're about to do an integral, and if f isn't continuous, then the integral wouldn't be defined. Okay, so f is continuous. Table of values below. If a right sum with 2 subintervals is equal to 63, solve for k. Okay, so I would, draw a sketch. All right. So 0, 12. All right, so here's 0. I'll say that this is 12. Let's say that this is 3, and let's say that this is 6. Okay, now I'll say that this is 3. And K, I don't know what it is. That's what I'm solving for. I don't know if K is up here. I don't know if it's down here. I don't know. I'm just going to place it so that my picture looks, so K question mark maybe. I'm just going to place it somewhere so that I can get a nice visual. Okay, so at 0 we got 12, and then at 6 we've got 3. Okay, so this is a continuous function, so I'll just draw a continuous function. Now a right sum goes like this. Okay, in two subintervals. So one subinterval, two subintervals. Okay, a right sum, they usually say a right Riemann sum, but I guess they sometimes just say a right sum. And in either case, it means you're using rectangles. So this is the base of the first rectangle. And then for the height, I go to the right end point. That's why it's called a right sum. And then from there, I go up to the graph. And then I just complete that rectangle. Okay? And then for the next interval, same thing. So this is the base of the rectangle. It's a right sum. So you go from the right end point of the subinterval up to the graph and complete the rectangle. Okay, so we are estimating the area. This is a horrible estimate, really, because the rectangles are so big. So I've got to estimate these. All right. So for the green one, okay. So I'm gonna get this. So really, we've got the integral from 0 to 6 of f of x dx is approximately, okay, so we're going to do base times height, base times height. Okay, so base times height, base times height. So the base of the green one is 3. The height of the green one is k. The base of the pink one is 3. And the height of the pink one is 3. Okay, so this is approximately 3k plus 9. Now they're telling us that this approximation is equal to 63. So 3k plus 9 equals 63. Then 3k equals 63 minus 9 is 54, I think. 54 divided by 3 is, what is that? 18 maybe, I think? Yikes. I don't know. I think it is, right? 30? Yeah, it is. Okay, 9. So I'm telling you here that, okay, so there's a particle on the x-axis, and I'm telling you that its position is 10 at t equals 4. And actually, this is kind of confusing. So let's change this to 5 because I don't want to use 10 twice. Okay, so the position of the particle on the x-axis is 10 at time t equals 4. If the velocity of the particle is given by this, we want to find this. Okay? So the question, as usual, is limit derivative or antiderivative. This is the antiderivative because velocity is the first derivative of position. So this is antiderivative. All right? So, guys, what you really need to use, just a second, or what I would use here what I would use, let me find it. This is from your salmon packet. I would use the antiderivative with an integral formula. This is a formula that you could use if you know just one value of the antiderivative that you're looking for, and you know the derivative of the antiderivative that you're looking for, then you could always use this formula. So I'm going to write it down. So it goes like this. It says, so let me just write the formula down as it is. It says f of t equals f of a plus the integral from a to t, and then f prime of w dw. This is a dummy variable, w. It's just a placeholder, and it has to be different than this variable. This is not a dummy variable. This variable stands for time. This variable is just a placeholder. Okay, so what's going in for f? It's the function x. So x of t equals x of 4, because that's what we know, plus the integral from 4 to t, and then in here goes 2w minus 5 dw. But I want x of 5. So I've got to go x of 5 equals, now what is x of 4? It's 10. All right, this is the position function, and they told us at the beginning that its position is 10 at that time. So 4 to 5, input goes up here, and then 2w minus 5 dw. Okay, now this is equal to, now this is a no calculator section, so I'm going to use the fundamental theorem of calculus. So you set up the brackets, that's where the endpoints of the interval go, and the antiderivative goes inside. So this is where you're actually taking the antiderivative. So this is w squared minus 5w. Okay, which is equal to the 10 I just carried over, plus 5 goes in. So that's 25. Oh, that's nice. 25 minus 25 minus, now 4 goes in. 16 minus 20. All right, so these are actually canceling. And I get 10 minus negative 4. Okay, so this is the position of the particle at t equals 5. Okay. Almost done. Okay, so now here's number 10. This was hard for me to come up with a similar example, so I'm just going to go like this. So we're going to do 2 separate examples. So here's one. I'm dealing with a rational function. I am told that this function, whose graph I'm looking at, is this, x plus b over x minus 1. And we want to solve for b. All right. Now, when you're dealing with a rational function, you could, or actually, I'll just say it. Okay. Guys, I notice that the y-intercept is 12. So since the y-intercept is 12, that means that f of 0 equals 12. All right? So let me do f of 0. So if I plug in 0, I get f of 0 equals b over negative 1. So this has to be equal to 12. So I get that negative b equals 12, so b equals 12. Okay, now this one. All right, so this time, the b, so here b was one of the constant terms. This time, b is a coefficient on one of the leading terms. And guys, if it's the leading terms that determine the asymptotes of a rational function. And here I've got that this horizontal asymptote is 2. So this here, this means that the limit as x approaches infinity of f of x is equal to 2. That's the definition of a horizontal asymptote. It's end behavior. That's what it's called. So I've just got to do the limit of this and set it equal to 2 and see what happens. So I'll go the limit as x approaches infinity of this function. But guys, I'm just going to save us writing room. I'm just going to take this is called the end behavior model, and you take the leading terms. All right? And now these are canceling. So this is the limit as x approaches infinity of b over 2. Now, b is a constant, and 2 is a constant. So as x gets bigger and bigger and bigger, b and 2 don't change at all. All right, so that's just b over 2. So, extra room. So I'll be like, therefore, b over 2 equals 2. So b equals 4. All right, and then there is the similar example.